Hey guys, welcome to my channel. This video is dedicated to solving practice problem 1 in the Unit 6 Lesson 4 packet, so let's get started. The Ka for Nason is 1.5 times 10 to the negative 5. Calculate the pH of a 0.01 molar solution of Nason. Okay, so calculating the pH of a weak something. I know I'm going to use a rice table, but the real question is, what is my equation going to look like? Am I dealing with an acid or a base? How do I know? Well, I am given the Ka for Nason. So, Nason is going to be a weak acid. And I don't know the formula for it, so I'm just going to use a generic term for acid, and I'm going to call it HA. So since I'm working with an acid, I'm going to use an abbreviated dissociation equation. HA dissociates into H plus and A minus. All right. So we know that my initial concentration of HA, my weak acid, aka Nason, is 0.01. My initial concentration of H plus and A minus we're going to assume are 0. Because there are no products present, the reaction can only shift right. The amount of Nason is going to change by minus X, while the amount of H plus and A minus also change by plus X. Now I set up my equilibrium. And I am going to now relate these terms using my Ka expression. So my expression is Ka is equal to H plus, the concentration of H plus times the concentration of A minus, all over the concentration of HA. My Ka is equal to 1.5 times 10 to the negative 5th. My concentration of H plus is X. My concentration of A is also X, divided by my equilibrium concentration of my acid, which is Nason. Remember, we are dealing with a weak acid with a very small dissociation constant, so we are going to assume that the impact of dissociation on the concentration of our acid is negligible. So we are just going to assume that that's 0. And I've removed that term from my expression. I solve this and I get that X is equal to 3.87 times 10 to the negative 4. Going to fill out the solutions row. Abbreviating 10 to the as E just to conserve space. And now I know my equilibrium concentration of H plus, and so I can use that to solve for my pH. And I finally get that my pH is equal to 3.41. All right, see you guys for the next one.